We're here at the Colorado School of Mines, and what are we going to be doing, Daniel?
Well, when you're mining, you need to use explosives a lot of the time.
Yeah.
Right. So that's what we're going to be doing. We're going to be using
quicker
explosives.
than a shovel.
Exactly. Except for instead of using it for mining, we're going to be using it for SlowMo Guys purposes.
Yeah.
Which involves a toilet, a safe,
some mannequins.
Some mannequins.
Some mannequins are going to bite it.
Plenty of explosives.
We also have an absolute myriad of phantoms to get an absolute range of resolution and frame rates. So let's have a blast. Over here, in this giant metal protective box, we've got two Phantom v2512. This one is set to 28,500 frames a second. This one is set to 207,000 frames a second. So it's very low resolution, but very, very fast. Also, up there in that yellow box, we've got a v2640, which will be at HD at about 12,000 frames a second. This is the first of 3 explosions. First up is a toilet that didn't stand a chance. For this shot, we wanted to see the trajectory of ceramic fragments from the toilet, so it was ideal that we had 3 cameras running at different frame rates in different positions. This was easy because Phantom has a wide range of cameras for lots of different purposes and positions. Each of these cameras can be synced together so that the timestamps match when the footage is reviewed. This is useful for engineers who want to look at frames from each shot to find the same point in time and measure the speed, angles and rotation of specific items within the blast. The top view is from the Phantom v2640, which has a 4 megapixel resolution and a stunning image quality. I think the detail we got in this shot just shows off the incredible dynamic range of this camera. This is also pretty much straight out of the camera, barely edited this shot. Our second explosive test was using a shape charge to break through the door of a safe. We used 2 Phantom v2512 cameras from more or less the same position but at different frame rates. One was to get a really high frame rate of over 100,000 frames per second on the right, and the other one is to show more of an overview with more resolution. The ignition blast is over in about 6 seconds on the left, and the same thing lasts 24 seconds on the right, so you end up with much more usable data for something that moves so fast. And our final explosion of the day was a very, very big one. Oh, that looks like the end of the world.
Oh, you can see it.
Oh, there's like
Sparks and flashes from the...
Or it's usually the rock, or maybe just fast-moving plastic, fast enough where it's actually igniting on impact. It honestly looks like that was fired from a fat man.
It does. That's what it looks like in Fallout.
And then, once you see the shockwave go up, you see it moving across all this floor back here. See, it's got up there, and then it's lifting up all of the dirt, and now it's imploding back down. That might be one of the best and most well-defined shockwaves I've ever seen. There's actually enough resolution here that you can zoom in and notice that after the initial shockwave, there are smaller residual shockwaves that bounce off objects and start to deflect into each other. This was our last shot of the day. It was an incredible one, and the perfect angle to capture this. That might be one of the most mental videos we've ever made.
It's insane. I'll tell you, that was a lot of explosives.
Yeah. Well, big thanks to Vision Research for setting this up and letting us use their Phantoms in an extremely dangerous environment. And thanks to the Colorado School of Mines for letting us come and blow stuff up here.